So the second technique for factoring is called as difference of squares. So if you have quadratic expressions, so what happens is that you can have two functions, two expressions, not two functions, and each of them can actually be written as a square, and the other condition is that in the middle has to be a minus. So in between those two square functions, it is going to be a minus. It cannot be a plus, so you can use this technique. Cannot be a plus. Okay, so the outcome is going to be x minus a multiplied by x plus a. So actually, the general formula is going to be something like this. If I have a function f being square minus a function g being square, so the factorization is going to be f plus g multiplied by f minus g. Oh, that actually go up beyond my screen. So f plus g multiplied by f minus g. Or it could be also the other way around. I can put minus at the front and plus at the back. So that's also fine. As long as one is going to be plus, one is going to be a minus. But the condition is that before you start using this difference of square technique, so you have to make sure that both of the function is being square. So that will be the first thing that you have to make sure of. So let's start with the example. So example number 1 is going to be the easiest. I simply have a function of x squared minus 16. So the good news is that the first term is already being square, so I don't have to deal with that anymore. But I have to change the function at the back, and this is minus, so it satisfies the condition in order to use this technique as well. But 16 over here, it can actually be written as 4 to the power of 2. So now that both of them are being square, so all I have to do is I'm going to take the function down here, which is our f and our g, and I'm going to make a product of them. One is going to be plus, one is going to be a minus. So for this case, I'll end up with x plus 4 multiplied by x minus 4. And as I mentioned to you before, it could also be the other way around. So it could also be written as x minus 4 multiplied by x plus 4. So either way is correct. So that will be the first example. So for the second example, so I have 2x cubed plus, sorry, it's going to be minus. So that should be a minus of 18x. So I have a problem right here because when I have a look at the function, both of them are not being square. In fact, I even have x to the power of 3, and this is x to the power of 1. So what I will do is, before I start using the formula, I'm going to factor them first because I noticed that there are common terms between them. So first is that both constants are multiple of 2, so I'm going to factor out the 2, and both are multiplied by x, and the smallest variable is going to be x to the power of 1, so I'm going to factor out 2x. And the first term is going to be x to the power of 2 minus, and the second term is going to be 9. Okay, so we notice, so there's something going on over here. I can actually write this as 2x multiplied by x squared minus 9. We know that 9 is going to be 3 squared. Then only I can apply the formula. So now it satisfies all the conditions. This is already being square. So therefore, I can simply write that this is going to equal 2x, x minus 3 multiplied by x plus 3. Right, so that is going to be the factorization. And of course, like, how do I know how to stop here? Because when I have a look at my factor, so this is already the smallest, x to the power of 1 and x to the power of 1. If it x to the power of 2, 3, 4 and so on, 2 and above, then only you check whether they are reducible or irreducible. If it's already linear, then we know that that's the smallest it could be. Okay, example number 3. So I have it in the form of a minus 4b squared, so minus 36. So that is how actually the function actually looks like. And do not get intimidated the fact that we have more terms than we usually have. For the previous two, we only have 2 terms in here. So this 1 and 2, 1 and 2. But for this one, in fact, I have 3, 1, 2 and 3. But the thing is that these two, they actually come together and they are already being square. So I don't have to do anything about them. I can simply take the whole thing. So I can actually write that. This is going to equal, so a minus 4b squared. So minus, we know that 36 is going to be 6 to the power of 2. So what is going to be my f and g? So this whole thing over here is going to be my f, and this is going to be g. So this f and this is going to be g. And now when I wanted to write down the factorization, so this is going to be simply, so put a bracket, but because this is already a round bracket, I'm going to use a square bracket instead. So my f function is a minus 4b minus 6, close bracket, so that would be my first factor. And the second factor is going to be another bracket. F is going to be a minus 4b, and it's going to be plus 6. Okay, and if you can actually simplify what goes inside, simplify them. But if you cannot, just leave it like this. For this case, then we're just going to leave it like that, because I cannot simplify a, b, and 6. They are not related. Okay, so the fourth one. The fourth one, I have y to the power of 4 minus 1. Okay, so this one you have to modify a little bit again. So here I don't have a square in the function, so I know that the one I can actually write it as 1 squared, because 1 squared is still 1. But the problem here is that this is going to be y to the power of 4, not a square. But we know that 4 is actually a multiple of 2, so we can actually make it in terms of 2. So how am I supposed to do that? So I can actually write this as y to the power of 2 square, so minus 1 square. So therefore, for this case, our f is going to be this whole thing, and this is going to be our g. So why is it going to be y to the power of 4? Because this is the same level. When it's same level, you multiply them. 2 multiplied by 2, so that is how it becomes 4. So here I will end up with y square minus 1 and y square plus 1, or it's the other way around, it doesn't matter. So I will leave out a square right there. Okay, so that is going to be y to the power of 4 minus 1. And the fifth example, I'm just going to show you the fifth. 9 x squared minus 2. Okay, so the first idea is make everything in terms of square. So what I'm going to do is the 9x, how do I create a square of that? It has to be together. So 9x is actually 3 to the power of 2. So basically this function is 3 to the power of 2, x to the power of 2 minus, and we know that a square is going to equal 2. Okay, so what is going to be a? So a is going to equal square root of 2. So that's why here this can actually be written as square root 2 to the power of 2. So now both of my function are going to be square, because this two, because they are product. This only apply for product. I can actually write that this is going to be 3x to the power of 2. So minus square root 2 to the power of 2. So this is my f and g, and I'll end up with my f, which is 3x minus square root of 2 multiplied by 3x plus square root of 2. Okay, so that is going to be the fifth one. So you have to find a way on how is it possible to actually make it in terms of a square. And the last one, okay, the thing is that when you have like an example, I'm always going to give you plenty of example. For example, for this case here, I actually give 6. But if you actually got the idea already after the third example, you don't have to see until the end. So you can just skip it and proceed to the exercise. You don't have to see until the end. So, but if you still have problem and want to see more, then only proceed to watching the video, because it's very flexible. When you have the video, you can simply skip it. You can simply, like, you can watch until the extent that you want. That's it. But the only point is that you have to really understand what's going on. Alright, so I'm going to proceed with the sixth one, the last example. I have 5x squared minus 5x. So here my common factor will be 5x. So I'm going to factorize it. So the first term is going to be x to the power of 4, and then I'm going to have minus 1. So this is going to be pretty similar to example number 4. So the only difference is that instead of y, I have x. And I know that this is going to be 5x multiplied by y to the 2 minus 1. So multiplied by y to the 2 plus 1. Actually, I did a mistake here when I do question number 4, because if you notice, I have to the power of 2 right there. And when I have a non-linear factor, power of 2 and above, I have to check whether they are reducible or irreducible. And for this case, it doesn't matter because this one is irreducible. But this one over here, it is actually reducible. I actually have to proceed further. So actually the solution of this, because I know that y squared minus 1, so that is going to be y plus 1 y minus 1 multiplied by y squared plus 1. So which is what I'm going to do for this one as well. So this is going to be 5x. So y squared minus 1 is going to be y plus 1, y minus 1. So multiplied by y squared plus 1. So that is going to be the end of the calculation. Remember, so when it is not linear, so you have to always check whether it's reducible or irreducible. Because if you still leave it in reducible form, your job is not done yet. Okay. So we have like 5 altogether.